Hi everyone, let's talk 4D, which is about loan payments, credit cards, mortgages, that sort of, it's just loans in general. We're going to try to make this so that it's a little bit relevant to your situation. Okay, in our last lesson we started, when we were looking at savings, we started with a balance of 0 and started adding equal monthly payments and ended up with a balance of whatever. Now we're looking at this backwards. We're looking at a loan, so we're going to start with some balance and we're going to make monthly payments and then we're going to end up with a balance of 0. So before we were making deposits and now we're making withdrawals, and so it's the process is backwards. And it changes the formula, so this is where it really gets confusing, that it changes them just enough to make it confusing. Okay, so we're going to, in essence, you'll notice that this is exactly what we did in 4C for a savings plan, but let's go ahead and do the same thing now for a loan and see why it is different. Okay, so suppose you owe $10,000 on a loan that you financed at 9%. You have to make monthly payments that at least cover the month's interest, but you don't have to pay off the loan in any particular period of time. So you get to kind of make the decision. Okay, so if the APR is 9%, what is the interest rate each month, because we're dealing with monthly payments? Well, of course, we're going to do exactly what we did before. We're going to take our APR, which is 0.09, divided by 12, and that gives us 0.0075, which is 0.75%. Of course, this is what we're going to use in our formula is decimal form. Okay, so we want to find the balance of the loan at the end of each month if we make regular monthly payments of $100. Now notice, before we had the starting balance plus the interest plus the end of the month payment. But now we're starting with a balance and we're going to go down, so we're going to subtract that payment. So we start at $10,000. The interest accrued is going to be 0.0075 times the starting balance, which gives us $75. Our monthly payment is $100. So now we've got 10,000 plus 75 minus 100, and that gives us an ending balance of $9,975. Just like on the savings, this becomes our starting balance, so $99.75. The accrued interest is going to be 0.0075 times that starting balance, which is $74.81. The payment is still $100, and we end up with $99.49.81. Now notice on each of these payments, our balance is not going down by $100 each month because we're adding the interest in. So even though we paid $100 here, our balance only went down $25 because we added the 75. Same thing here, it only went down another $25 roughly because we added roughly $75 in interest. Okay, we're going to continue along. This is $99.49.81. The accrued interest, if I multiply 0.0075 times this, I get $74.62 minus the $100 payment, and I get $99.24.43. That becomes my beginning balance in month 4. If I calculate 0.0075 times this amount, the interest is $74.43. I would add that, then subtract the $100 payment, and my ending balance at the end of 4 months is $98.98.86. Okay. All right, well, let's look at this. How much interest was accrued? Well, I'm just going to add these up. And so I get 75 plus 74.81, 74.62, $74.43, and I end up with $298.86. What are the total payments? That's $100 for each of 4 months, so that's going to be $400. So if I made payments of $400 and $298.86 is interest, to reduce the loan, this is just going to be the 400 minus the 298.86, which means I've actually only paid down the loan by $101.14. Okay. All right, so how many times would you need to perform this calculation to find the balance in 10 years? Well, I'd have to do it 12 times a year times 10 years, and that would give me 120. Again, this is too many. This is where we need a formula. Okay, so here are the formulas, and if you look at your formula chart, these are very, very similar, but to the savings, but notice there's no A in here. There is no accumulated balance, because our accumulated balance, we want it to be 0. We want it to end up at 0. But instead we go back to using principal. It's the same thing. Okay, so the payment to the PMT, of course, is the regular payment amount. The P is the principal, which is the amount borrowed. The APR is the interest rate as a decimal. Remember to change as a decimal. N is the number of payments per year. And finally, N is, or Y is the number of years. Okay, now just like the savings, we could either find how much we needed to put every month to get a balance, or if we had a balance, how much the payment would be. We can do the exact same thing here. So notice this is solved for P, this first one here, which means we want to use this formula if we want to find the loan amount. Okay. If I make payments for $183.19 for 25 years, what was the amount that would pay off? What was the amount of the loan? If I'm solving for payment, PMT, that means I want to find the regular payment. Okay. This would be, okay, I've got a $200,000 loan. I'm going to pay it off in 30 years at 2% interest. What are my monthly payments going to be? Okay, so that basically is the entire lesson. You're just going to need to keep these formulas handy, and we will just do some examples. Okay, so we're going to go back to this same example, which is 10%, I'm sorry, $10,000 at 9% making monthly payments. Okay, suppose you want to repay the loan in 10 years. Use the formula to calculate the amount of the monthly payment. Okay, so that means I want to know what is the payment. Okay, well, I've got all these other variables, the P, the APR, the N, and the Y, and I have to know all of those in order to solve for this. Well, we know the principal, the loan amount, is $10,000. The APR is 9%, which becomes 0.09. The N is said it was monthly, and the Y, we want to pay it off in 10 years. Okay, so using the formula, the payment is going to be the P, the principal, times the APR divided by N, all divided by 1 minus 1 plus the APR divided by N to the negative N times Y. Now, most of us have a calculator where we want to put all of this in, so in our and we'll come back then and find out what the payment is equal to. But in our calculator, this is going to be 10,000 times 0.09 divided by 12, all divided by 1 minus 1 plus 0.09 divided by 12 to the negative 12 times 10, and then we have to close our parentheses. And when I do that, I get that the payment is $126.68. Okay. All right, suppose you wanted to make monthly payments of $170 for 8 years. Will this pay off the loan? Well, now we're going to use our other. So if I make $170 for 8 years, what would the principal be? So in this situation, the P is what I'm looking for. So I'm going to use the formula where I solve for P. So the payment is $170. The P is what we're looking for. The APR is 0.09, or 9%. Our N is 12, and our Y is 8. So that formula would be P is equal to 170 times 1 minus 1 plus 0.09 divided by 12 to the negative 12 times 8. And all of this is divided by 0.09 divided by 12. In our calculator, this would be 170 times 1 minus 1 plus 0.09 divided by 12 to the negative 12 times 8. I have to close both parentheses, divided by 0.09 divided by 12. And that gives me $11,603.93. So to answer the question, yes. You would not need the entire 8 years to pay off the loan. Now, through guess and check, you could find it more exactly, but that's an awful lot of time. Okay, so let's talk about something that is going to be a little bit more relevant to you, and that is going to be student loans. My guess is that several of you are going to walk away from college with some student loans. And they're great now, but you have to remember that they have to be paid back. So let's talk about that. All right, so suppose you have accumulated $17,500 in student loans when you graduate. The interest rate is determined by the term of the loan, and you have two options. Now, this is very common in finances. Notice here is 8.5% for 15 years, 8% for 10 years. The shorter the term, the lower the rate. The longer the term, the higher the rate. That isn't always the case, but that's very common. Okay, so in option A, we want to find the payment. So I'm going to use the formula that calls for payment equals. Okay. Now, I did not leave quite enough room for this, but that's what I need to know. So my principal is $17,500. The APR is 0.085. The N is monthly, so that's 12. And finally, my Y is 15. Okay. So my payment is equal to 17,500 times, and for the payment formula, to find the payment, I'm going to use this one. So it is going to be 0.085 divided by 12, all divided by 1 minus times 1 plus 0.085 divided by 12 to the negative 12 times 15. Now again, in your calculator, that is going to be 17.5 times 0.085 divided by 12 divided by 1 minus 1 plus 0.085 divided by 12 to the negative 12 times 15, and close both parentheses. And the payment turns out to be $172.33. So you would pay $172.33 for this loan every month for 15 years. Okay. Well, I'm going to do this one, and I'm hopeful you will do this one on your own and then compare them. Okay, over the term of the loan, the total payments would be the payment times the number of payments. So that's going to be 172.33, and the number of payments is going to be 12 per month for 15 years, 12 months for each of 15 years. So you end up paying $31,019.40. So you borrowed $17,500, but you're actually paying them $31,000. So that means there's a bunch of interest paid. So the total interest paid is going to be the total payments minus the principal, which is going to be $31,019.40 minus 17.5, which means in interest you paid $13,519.40. Okay. All right, now we're going to mimic this exactly. The only thing that's going to change here is going to be our APR and our years. We still want to know what the payment is going to be. Our principal is still the $17,500. The APR is now 0.08, still monthly payments, but 10 years. So the payment is equal to 17.5 times 0.08 divided by 12 divided by 1 minus 1 plus 0.08 divided by 12 to the negative 12 times 10. And that gives us a payment of $212. Whoops, that's not much of a 212.32. Now you can mimic this exactly in your calculator and see what happens. Okay, the total payments over the term of the loan is the amount of the payment times the number of payments. So this is going to be 212.32 times 12 payments each year for 10 years. And that gives you $25,478.40. So the total interest paid will be the total payments minus the principal. So this will be $25,478.40 minus $17,500, which gives me $79.78.40. And that may be 41. I may have done that one. Okay. All right. So you can see there's a substantial difference in the total amount that you pay for the loan. But the payments are more and the term is less. Now, what are the factors that you would use to determine your decision? You could use things like the total interest paid, total of payments, the term of the loan, how much you can afford. You know, it would be nice to get it paid off in 10 years, but if $212 is really going to stretch your budget, that may not be the way you want to go. Okay. So let's talk now about credit cards. Credit cards, and I will tell you, you are not alone if, you know, this past year has really been tough, and probably a lot of people have utilized their credit cards more than they thought they ever would. So, you know, it happens. It's okay. But now that things are beginning to get back to normal, you want to pay those things off. Okay. So, you have one credit card that has a balance of $1,200 and charges an annual interest rate of 24.5. You decide you want to tear up the car and pay off the balance. Okay. So if you want to pay off the card in 1 year, how much must you pay each month? Okay, well, we're going to go back and use the formula to find the regular payment. Okay, so I'm going to put it over here. So the payment is what we want. The principal, we know we owe $1,200. The APR is 0.245. That's 24.5 converted to a decimal. The N is 12. And we want to look at this just for 1 year. Okay, so we know the payment is equal to the $1,200 times 0.245 divided by 12, all divided by 1 minus 1 plus 0.245 divided by 12, to the negative 12 times 1, and put that all in parentheses. And you get that the payment is $113.76. Now once again in your calculator, this is going to be 1200 times 0.245 divided by 12 divided by 1 minus 1 plus 0.245 divided by 12 to the negative 12 times 1. Now in your calculator, make sure that you are opening and closing your parentheses. That's one reason I have you write it all down like this before you put it in your calculator. But also make sure for this negative here that on your calculator, whichever one it is, you are going to have the operator that is the minus sign and then something like this that changes the sign. This is what you want to do. This means minus, this means negative, or the opposite. Okay, so how much interest over the year? Of course, that's going to be the total of the payments minus the principal. The total payments, you're going to make 12 payments of $113.76 and then subtract the 1200, which means you're going to pay $165 in interest. Not that bad. I mean, again, it was there and handy for you when you had an emergency, but now you want to pay it off. Okay. All right, suppose now that you want to pay it off in 2 years. How much would you pay each year? $113 is out of your budget. So you want to find out if you do it in 2 years, what could you do? You could do this for 18 months, or 3 years or whatever. All that's going to do is change this to a 2. Everything else is remaining the same. So the payment will now be 1200 times 0.245 divided by 12, all divided by 1 minus 1 plus 0.245 divided by 12 to the negative 12 times 1. And make sure you close that parentheses. And you end up with a payment of $63.75. Okay. How much will you pay in interest over 2 years? Well, again, that's going to be the total payments minus the principal. Well, your payment, you made 24 payments, which is 2 times 12. So 24 times $63.75 minus what you borrowed, the $1,200, and you end up paying $330 in interest. Okay, again, not bad. Okay, but you have to decide what's right for you. Okay, time to switch videos.